Hello there, and then welcome to this video. In this video, we'll be looking at probability rules. Now, we've looked at two of these probability rules. That is the rule relating to addition and then that relating to multiplication. In this video, we'll be looking at is relating to complementary events. Complementary events. So, what is complementary event? What at all is complementary event, and how do we solve questions relating to complementary events? That is what we'll be looking at, so please stay tuned. So when we talk of complementary events, a complementary event or complementary event, so they are pair of events where one event occurs if and only if the other does not occur. You see, these two events can never occur together. One occurs only if the other does not occur. So for instance, if A is a probability of getting the head of a coin, then this over here becomes what? The event of not getting a head. Right? So A becomes the main event, AC, or we say the complement of A becomes the what? The complementary event. So all together they form the possible outcome of an experiment. Soon we'll be looking at a relation between them. Now, the complementary rule formula, it says if probability of A is the probability of event A, then the probability of the complementary event is given by probability of A. So it's given by what we have over here. That is 1 minus the probability of A. What this simply means is if you have the probability of A, then you can always solve for what? The probability of the complementary event. So if we have the probability of A, we can always solve for what? The probability of the complementary event, which is what? From what we have above here. So the probability of the complementary event is equal to 1 minus the probability of A. Do you see that? This should tell us then that the probability of A, let me write that with another. So this should tell us that the probability of A plus the probability of its complement is always equal to 1. Do you see that? Take your time and observe that. Because if we are to make 1 the subject and probability of A goes to the left hand side over here, then instead of positive, it's going to become, instead of the negative we have here, it's going to become a positive. Do you see? So hence we can also get this formula that the probability of A is also equal to 1 minus the probability of its complementary. You see, so they both work hand in hand, right? Now, if the understanding of that has been established, in this video I wouldn't be going deep into the questions, but then I have already solved them and I'll explain to make the understanding clear. Okay. Now, probability of tossing a coin is given as what? 0.5, as you can see here. Now, what is the probability of the complement? So if we are talking of tossing a coin, then the complementary event is going to be not tossing a coin. And we want the probability of not tossing a coin. So if the probability of not tossing a coin is A to the power C over here, or A complement over here, then using our complementary rule, which says we have 1 minus the probability of A, substituting, we have 1 minus 0.5. You see? So we are saying that the probability of a complementary event is equal to 1 minus the probability of the event itself. We already know this one's value. So substituting, we have 1 minus its value, which is 0.5. Then we do our subtraction. 1 minus 0.5 gives us a 0.5. And that becomes our answer. So hence the probability of obtaining its complement is what? 0.5. So let's look at another example. Now this example has to do with rolling of a die. So it says the event of rolling a die is actually what? The probability of the event of rolling a die is 1/6. What then is the probability of not rolling? Oh, well, it says the probability, the event of rolling a 4. We have a 4 over here. Right? Is 1/6. So the question is, what is the probability of not rolling a 4? So using our complementary rule, which is 1 minus the probability of the event is equal to the probability of the complement. That is probability of a complementary event being 1 minus the probability of the event itself. They are going to get 1 minus, this time around we have 1/6, right? And solving this, our LCM being what? 6, and we have a 6. That is 1 into 6, giving us 6 minus 1. We are going to get a 5/6. All right. So the probability of not rolling a 4, could be you rolling 1, you rolling 2, you rolling 3, you rolling 5, and then 6. All these numbers are what? The complement of the event of rolling a 4. All right. Yes. So that is that. As we can see, the formula of what? Complementary event is really helping us easily get these values. Now this has to do with drawing a card. A standard deck, as we all know, has 52 cards. Now we want to just draw a spade, and they are saying its probability is what? 13/2. Remember from our previous video, we learned that there are 13 spades, 13 diamonds, 13 clubs, right, and 13 hearts. So if you want to draw a spade, its probability is 13/52. Then not drawing a spade would then be either drawing a diamond, a club, or all the other cards, you see, but not a spade. Hence, using our complementary rule, it applies here as well. 1 minus that which favors the event, and 1 minus 13/52 then gives us 59. All right. So let's look at some 2 practical questions, and then I'll leave some other practice questions as well. This one says the probability of it raining is actually 70%. So that is what we have over here. What then is the probability of there being no rain? No rain. So using our complementary rule, we have 1 minus that which we know, the probability of the event. So 1 minus 0.7. We know 70% can be written as what? 0.7, which gives us a 0.3. Changing it into percentage, it says thus there is a 30% probability of what? It's raining. It's not raining. Then let's look at our last question. It says a factory finds that 90%. So 90% of product pass quality inspection. That is probability of that event. The event we are talking about here is it passing quality inspection. and 90% written as decimal is 0.95. What is the probability of a product failing, that is it not passing the quality inspection? So using our complementary rule, we have 1 minus the probability of it passing. So 1 minus 0.95 here, which then gives us 0.5. You see, so this means that there is a 5% probability of the product fails. You see, so this means that 5% of the probability of the product, 5% of the product fail the quality inspection. So that will be it for this particular video. If you found this video helpful, you can choose to subscribe for more content so that anytime I release any video, you'll be notified as well. Thank you very much for staying to the end of this video. These are some practical questions you can solve and then reflect on to test your understanding. Bye bye.